Good afternoon, friends and colleagues from around Puerto Rico and the rest of the United States and the world. We are so happy to welcome you back to the third session of the Keep Safe training series, Building Climate Safe Homes. And we're so excited today to be with our dear colleagues, Jonathan Marvell, Paul Fericelli, Jose Juan Teresa, to discuss the most critical and fundamental aspect of resiliency, which is water and energy solutions. We're going to just wait to get some of our colleagues to join. As everyone's getting ready, I'm going to launch a poll. For some reason it's not launching, but here we go. Please tell us where you're from. Andrea, there's another poll in there if we could just get, if that's possible to get queued up. Oh, that's good. Fantastic. We have a lot of friends and colleagues here from Puerto Rico, from Europe, from New Orleans, from Miami, California, Hawaii, USVI, Germany, Saudi Arabia, Mexico, Venezuela, Colombia, Puerto Rico. Thank you all. And as everyone keeps sharing where you're from, feel free to chat and let us know where you're from as well. This is a universal audience. We are very pleased to be here with you today. And we're so thankful to some of our key partners and sponsors for making this possible today. I'd like to first thank El Vocero de Puerto Rico for coming in as a sponsor for our sessions. Thank you to the whole family at El Vocero de Puerto Rico. Also Simpson Strong Tie. Those are the folks you want to get your hurricane straps from if you want to protect your houses. Thank you to the family of Simpson Strong Tie for coming in and supporting us. And all of our other partners, Fundación por la Arquitectura de Puerto Rico, Builders Association, the AIA of Puerto Rico, Habitat for Humanity, Colegio Arquitectos, Resilient Power Puerto Rico, of course. We're going to be hearing from the founder, Jonathan Marvell, and Jose today, the EPA, which has so gracefully enabled us to work with Paul Fericelli today, and so many more colleagues from around Puerto Rico that we're so thankful to you for coming in and helping to sponsor this. And just a little housekeeping, if anyone has Q&A or any questions, please send that question to the Q&A poll so we can answer that. My name is Lori Schumann. I'm the National Director of the Enterprise Disaster Recovery and Resiliency work. I work with an incredible team at Enterprise from around the country and Puerto Rico to ensure that housing that's affordable is going to be safeguarded for the future. We are so concerned about the twin crisis of affordable housing shortage and the fact that many houses are at direct harm's way from climate. The goal of these seminars is to understand critical actions and strategies that you can take to inform the design, construction, operation, maintenance of homes, identifying best practices and models in housing, and community-based resiliency strategies from across Puerto Rico, and how to scope these strategies. And we want to create a virtual community with all of you on the phone today, on the virtual world, to get this key information out at the height of storm season and throughout a time where climate change is incredibly volatile and threatens the security of all of us. The goal of today's session is to help you understand how to do several things: reduce water and energy consumption in your homes, collect, use, and treat rainwater for use, improve your septic waste disposal systems, prevent wastewater backup, reduce your energy usage, integrate solar, electrical, and thermal energy into your homes to make sure you have energy should the grid go down, and then design and install energy backup systems. We're going to accomplish a lot together in the next 90 minutes. Enterprise has been working in disaster recovery for 15 years. We just celebrated the 15th anniversary of Hurricane Katrina last week. So much has yet to be done, and the storms only seem to be growing more stronger and more violent. We have a lot at risk if we don't safeguard our homes from climate risk. And we know that every event that occurs, whether it's an earthquake in Ponce or Guanica, or a hurricane in San Juan, that homes are the first to go. And so many homes across Puerto Rico need more support to ensure that they're safeguarded from future risk, as well as homes in USVI and homes in Hawaii and homes throughout the US that have a need for stronger and safer rebuilding practices. And we know that the storms are only becoming more frequent. We've already hit records this hurricane season in terms of the strength and the rate in which these hurricanes are coming forward. A hurricane is forming right now in the Atlantic. So we have to make sure that we're aware of all of the risks and hazards that our communities are facing. In the first session, we discussed with Ada Manzon all of the different risks and all of the different issues that were at stake and how to understand and identify risk. We also discussed in the first session the importance of ensuring you understand what's happening on your site and safeguarding your site. And in today, in 2020, September 3rd, we also have another risk that has befallen our communities. And that risk is the risk of COVID and health pandemics. This is a risk that has caused millions, billions of people around the globe to shelter in place. Home has never been more important than it is now. It functions as a living environment, but also as a shelter for folks to keep away from the threat of the pandemic. In fact, yesterday, the CDC announced that there will be no more home evictions until the end of the year, because the recognition is homes are shelters. So people must remain in their homes so that they can be protected from pandemic. Homes are important and more important than ever before. Yet at the same time, many homes, and I'm showing a map of the United States, there are so many homes that are directly in harm's way. And we know that in Puerto Rico, specifically, there's a housing affordability crisis. There's just not enough safe and affordable homes. Families are struggling to make ends meet, especially now when tourism and retail has all fallen off. Families are living from paycheck to paycheck. And the average median income of many homeowners and families of four is $25,000 and less for many families across the island. And we also know at the same time, with the lack of affordable housing, that the floodplain is growing larger, that earthquakes are striking in areas that are densely populated like Ponce, and that there is an extreme climate risk. And we know that the world is changing, so we need to arm ourselves with the important information that we have to make sure that our homes and our families and our children and our generations to come are protected from what's happening today. Because one storm, one earthquake, one fire can undo years and years and generations of building in communities. We cannot let that happen. We need to protect and preserve our homes, our memories, and our culture by making sure homes are safe. So we got together with Resilient Power Puerto Rico and Builders Association and the University of Puerto Rico, and so many partners across Puerto Rico to build a guide for resilient and safe housing. This guide is called Keep Safe, Mantenerse Seguro. This is a guide for safe housing. And this was built over the course of 2 years with hundreds of leaders across Puerto Rico and the US to put together for you the most important and critical strategies that would be practical so that homeowners and designers and communities could build and retrofit their homes to be safe. The guide starts in a sequence where we start, just as this series is, with the introduction. How do you assess your risk of climate? And again, our introduction 2 weeks ago started with Adam Monzon on that. Then we move into your site. How do you make sure your site is fortified? And our session 1 covered that. Maria Roldan covered the green and gray infrastructure opportunities and opportunities to bring agriculture to your site and fortify it from landslides and flooding. And then we moved into building protection. And last week we were joined by 8 members of our team to discuss ways of protecting the structure and building a strong and safe house that ensures that you have the continual load path in place, that all members of the house are strong so that the house as a family would be strong or stronger in the face of a hurricane. We covered concrete homes and wood homes. We covered wood roofs and metal roofs, standing seam roofs. We covered anchors and straps. We covered foundations and walls. We covered wet flood proofing and dry flood proofing. And today we're so excited to bring to you some of the best minds I know of and best trainers on energy and water management. And we're going to cover a lot of territory today. And the next week, we're going to be joined by Dr. Fernando Abruña, who's going to give us an overview of what passive habitability is. How do you design and build a home? Should you lose power, it can still be habitable. We're going to then move into household preparedness and community engagement with a group of team members that are looking at community resiliency hubs and a representative from Puerto Rico's Emergency Preparedness Division and FEMA. And then we're going to finally close up our seminar with a seminar on how do you put this all together? How do you pay for this? How do you build it to code? And we're going to be joined by some special guests on that seminar as well. And so today I'm honored to introduce to you some colleagues that have really helped make it possible for this guide to be in place. First of all, I'd like to introduce, in order of speaking, Paul Fericelli. Paul Fericelli, we met many years ago at the EPA. We were asking around for help on trying to figure out how to incorporate the best kind of information on septic waste systems and potable water. And Paul stepped forward as an incredible expert and someone who has his eye on the ground. He leads the Smart Septic initiative in Puerto Rico, and he is an advisor to the EPA's Division of Environmental Protection for the recovery of Puerto Rico. He coordinates with FEMA and other agencies like the government of Puerto Rico's Housing Division and interest groups to provide technical, administrative, regulatory, and planning guidance. He's an engineer. He understands the importance of smart septic systems and safe water. He understands the importance of having water that's potable so your families are safe and healthy. And he also has the practical knowledge that we look for in an expert, someone who has on the ground experience. And so we're thankful for Paul being with us today. Then we're going to turn to Jonathan Marvell. Jonathan needs no introduction to many of you on the call. He was born in Puerto Rico. He lives both in Puerto Rico and in New York. He's an architect and an urban designer with over 30 years of experience across the nation, providing architectural planning, community economic, sustainable development, and resiliency insights. He's a true leader who has won multiple awards, has been cited by multiple organizations and industry leaders for his excellence in this work. He founded Resilient Power Puerto Rico to ensure that Puerto Rico has access to the best and the best in class of solar energy, and that energy would be deployed in a real way. And I trust Jonathan as a dear colleague and friend. He has been with us on this journey to create this book and this initiative like no other. And we're just so excited he can be with us today from Maine to talk with us about solar energy and electrical sustainability and resiliency. Thank you, Jonathan, for being with us. And with further ado, I'd like to introduce Jose Juan Teresa Soler. He is also with Marvel Architects and Resiliency Power Puerto Rico. He's a native of Arecibo, Puerto Rico. He's a registered certified landscape architect and has held numerous leadership positions across Puerto Rico and the US on sustainability, on governance, on efficiency. He is one of the premier minds of our time on resiliency and in energy sustainability. And we are so delighted Jose can be with us today. Welcome, Jose. Thank you for being with us. And without that, I would be remiss in not introducing our incredible team, OGMA, of women that are translating for us today. OGMA is a woman-owned translation firm based in San Juan, Puerto Rico. They are amazing. They've been with us through this entire journey. They've translated the entire book. They're incredible. Selena and Nicole are with us today, translating everything you're hearing. Thank you, Selena and Nicole, for being our eyes and ears to our friends on the call that are on the Spanish channel. Today, you will get credits for this class. If you are in Puerto Rico, you're going to get credits from the Colegio Arquitectos. They will have a credit for you. AIA National will have a credit for you if you're in the US. If you're an engineer and you need PDH credits, you'll get a credit. And if you're none of these and you just want a credit, we will provide you with a certificate of attendance, compliments of the University of Keep Safe. We will follow up with a sign-up sheet. You must attend the sessions to get credit. And without further ado, I would like to now turn this over to Paul Fericelli. Thank you, everyone. Welcome, Paul.
Hi, and thank you, Laurie, for this opportunity, and welcome everyone to the water management and storage training. Today, we're going to talk about strategies that can help address water needs when homes and facilities lose power or other services. We're going to be using as the main reference for this training the Keep Safe Guide. This is, as mentioned earlier, a guide that helps and supports resilient housing design. Next slide. Just before I start, I just would like to make the disclaimer that the views expressed in this presentation do not necessarily represent the views of or policies of the U.S. Environmental Protection Agency. These views and what I'm going to share with you, is based on my experience in my work in the water sector. Next slide. So let us ask ourselves why we're here. I believe that we all here because we want to learn and implement strategies that support resilient living before and after disasters. During extreme weather events and emergencies, drinking water can become scarce, can even get contaminated. And even sanitary services can get shut down due to power outages or broken pipes. Therefore, we need to prepare and implement strategies that help conserve and store water, and also strategies that properly treat and dispose wastewater. And by the implementation of these strategies, we're certainly going to be helping the resilience and sustainability of communities before and after disasters. So let us start talking with our the first strategy that we're going to be discussing today. Next slide, please. And that is reduce your water consumption. Let's talk about that. Understanding how much water is used at a household or building will really help the planning, design, and acquisition of equipment needed to implement water reduction strategies. It is very important. One of the first things that you need to do to start reducing your water consumption is to learn how much water you use. To determine your water use, you need to calculate the gallons per day and the gallons per person per day. And the good thing about the guide that we're using as a reference is that they have a tremendous calculator that can really help you to make these calculations very easy. All you need is just to check your water bill and just plug in and fill the blanks in the calculator. It is very important that as you as you implement the various strategies that we're going to be talking about today, you keep track of your water consumption, and you can do that by analyzing your water bill. That will really help you, to keep track of the conservation and the impact of the strategies in your water bill and also in your pocket. The next steps that we're going to be talking about is conserve water. And these have to do with actions that you and I do on a daily basis. Develop daily habits that support water conservation. Consume less water while showering, while brushing your teeth, washing your hands, washing dishes. Simple changes can really make a difference and can really help your reduction on water consumption. Next slide, please. Since we're aiming, right, to reduce our water consumption, you also need to check the equipment within the home that uses water. And you have to regularly check for leaks and monitor your water bill. So whenever you see irregular spikes in water use, you may have leaks in the plumbing system, or you may have leaks that are not so easy to identify by just looking. Therefore, it is recommended for you to hire a plumber so you can identify, so the plumber can help you to identify and find these leaks that are hard to see. If you see a leak and you can repair it, do it quickly. Do it quickly, since that really will help, to reduce the water consumption. One of the other practices that you can implement in a house or also, in a building is the installation of water efficient fixtures. And here in the United States, the U.S. Environmental Protection Agency have developed this program that is called WaterSense. When you install water efficient fixtures, that really help you in your water consumption reduction, and also can really help the cost of water that you're paying for that service. EPA has created an online inventory of water efficient products that meets EPA specifications for water efficiency and performance. And what does that mean? Basically, when you see a water efficient product that has the WaterSense label, that means that product, the performance of that product uses at least 20% less water than the federal water efficiency requirement. Therefore, that's where you really see the saving, because these products use less water and they continue to be functional. So it is very important that when you are planning for improvements and when you are planning, to reduce your water consumption at the house, you install these water efficient fixtures. So look for the WaterSense label in these type of products. Next slide. So when we think about water consumption, let us think about the opportunities of reuse water. And this is a very interesting practice, because you can have various water reuse opportunities. And let's talk first about gray water and how we can incorporate gray water into a house, or also how we can incorporate the reuse of gray water into a building. First of all, gray water is water that drains from the bathroom sinks, washing machines, bathtubs, and it can be used for toilet flushing or irrigation. And there are other uses and possibilities, just except drinking or bathing. You certainly do not want to use gray water for these type of uses. Treatment is needed, and the level of treatment will depend on the reuse opportunity of your interest. To this end, EPA has developed various guidelines and has been working collaboratively with states and also water utilities to develop recommendations on the level of treatment that is needed and also the water quality needed, just depending the reuse application. EPA does not require or restrict any type of water reuse in the United States. However, local government may have water safety requirements. So it is very important that when you are planning to incorporate gray water into your home or into your building, it is very important to check with the local water with the local water utility and also with the local health department, just to learn about the requirements for such practice. Again, EPA has developed various guidelines that can really help you on the various recommendations. I mean, there are certain recommendations in terms of the level of treatment for flushing toilets, for reuse applications on irrigations. So it is very important to check these guidelines and also check with your local health department. Next slide. Another type of possible reuse opportunity is through the collection and use of rainwater. This also is going to help you to conserve water and reduce our water consumption. So what is rainwater? So rainwater, when it rains, that is water that falls, right? So when we collect and store this rainwater, that is called rain harvesting. And yes, this is the collection and storage of rainwater for reuse. Similarly to gray water, it is not for drinking. But this particular case, it is not for drinking unless treated, and we're gonna talk later about that. So the first things, right, that you need to think about when you are planning to collect and store rainwater is to calculate the potential of rainwater capture, and that's where the roof of your home, the roof of your building comes very handy. And this practice involves, as I mentioned, the catchment area. And the roof can help on that. It also involves pipes, gutters that will help convey the rainwater into a cistern, and the cistern meaning a tank. And also it will involve the installation of a separate plumbing system for distribution of the harvested water into the building and to the various equipment that will be reusing the water. So let us talk about an equation, right? That is going to help us to determine what is the roof, what is the roof catchment potential. So to determine your roof catchment potential, you can do it by multiplying the annual catchment potential times your roof area footprint. The roof area footprint can be calculated from the ground, since the house perimeter has very similar dimensions as the roof. Make sure you are measuring your roof from one edge to the next. So that's how you. So that is right. The roof area footprint calculation. So now, when we're talking about the roof catchment potential, that can be calculated by multiplying the annual rainfall in your region by the following conversion. An inch of a rainfall on a square foot of surface area yields 0.623 gallons. And I'm going to repeat that. So we have that conversion in mind. An inch of a rainfall on a square foot of surface area yields 0.623 gallons. The annual rainfall of your region can be found here in the United States in NOAA maps, and this measure typically comes in inches of rain per year. I know this calculation may sound a little bit difficult, but the good thing about the Keep Safe guide is that they also have a calculator that can make this calculation easy. So once you have that data, you also have to look at possible improvements that you will need to do on your roof. And that is because the ideal slope for catchment is around 2%. So if you do not have that slope, you may need to conduct a couple of optimization so you can get that 2%. As you collect water, it is also very important to limit sources of contamination on your roof. So you want to have that area clear of possible sources of contamination. Also, as you are collecting this water, you want to flush out the first 5 minutes of the water collected. And that is also to reduce contamination, but in this case, at the tank. In this case, the cistern. The next steps will be, to select your cistern to supply your water needs for at least 2 weeks. In the beginning of this presentation, we talked about the calculation of your water consumption, how much water you use. So that calculation comes very handy in order to select and size your cistern. It is recommended that you at least size your system to address your water needs for at least 2 weeks. Remember, we're looking, say that after an emergency and say that the water service shut down, you at least can utilize this alternative to supply your water needs for at least 2 weeks. Also, the Safe Guide, the Keep Safe Guide provides a calculator for this equation. Once you have selected your cistern, you have sized it. Now let's think about where should we locate it. And it's like everything, location. I mean, there are various alternatives. I mean, you can locate it on the roof, you can elevate it above ground, or it can be on ground. I mean, something that is very important is that you have to make sure that if you're planning to locate your cistern on the roof, you have to make sure that your roof can actually support the load of the system. Water is heavy when it is in a cistern. Therefore, you have to check whether your roof can support that load, that load. So please check with a professional. In particular, a structural engineer can help you on that. As I mentioned before, treatment is needed if you're planning to reuse harvested water for drinking. Typically, this treatment involves filtration and disinfection. And if you're planning, to use it for drinking, you have to check with, in the United States, you have to check with your local health department and also, with the federal agency, EPA. So you can learn about the drinking water requirements and water quality regulations and treatment regulations. And that is if you're planning to use it for drinking. Otherwise, you can reference again the EPA guidelines about recommended level of treatment and water quality, just depending on the reuse opportunity of your interest. When we're talking about filtration, there are various ways that you can filter water. Some examples includes reverse osmosis, activated carbon, purification tablets, and a slow sand filtration. As any other type of equipment, you need to monitor and also to maintain, conduct like maintenance activities. So these filter and also treatment equipment can be maintained and providing the recommended and or required water quality that is needed. Last but not least is the distribution of your harvested water. And again, it is recommended to install a separate plumbing system around the house and around the house, for the various reuse opportunities of the harvested water in the home. Next slide, please. So far we have been talking about reduction of our water consumption, the various habits, and also the opportunities that we have under water reuse. So now let's talk about wastewater. Certainly wastewater, needs to be properly treated and disposed. And in this case, and in areas, in very remote areas or rural areas, not necessarily a centralized wastewater system is available for homes. A centralized wastewater system in Puerto Rico will be PRASA, which is the main wastewater utility in Puerto Rico, and in the rest of the United States, that would be any wastewater utility that conveys wastewater to a treatment facility. That is mostly found in urban areas, but in the suburbs and also in rural areas, what we have is a septic system. And what is a septic system? Well, septic systems are also wastewater infrastructure that help to treat and dispose wastewater. This infrastructure is underground, and it consists of two main components. One is a septic tank, and also two is a drain field. The design and size of these two components vary widely, and that is because there are various factors that trigger and various factors that you have to consider when designing this type of infrastructure. That includes the household size, the soil type, the lot size, the proximity of this infrastructure to water bodies, weather conditions. There also could be local environmental health and building code requirements. So certainly there's a variety of designs of septic tanks and drain field. But let us talk about the tank component. So the septic tank consists, as I mentioned, basically of two chambers. And again, this is like the typical configuration and the typical design of a septic tank. However, you may see a septic tank with only one chamber. So a septic tank, it is a watertight tank designated and constructed to receive and partially treat raw domestic sewage. The heavy, as the wastewater enters into the tank, the heavy solids settles at the bottom of the tank, and then lighter solids and grease remains on the top. Once that happens, the wastewater is then discharged into a leach field that will provide additional treatment and disposal for wastewater. When it comes to the leach fields, they are again like various configurations. The conventional configuration is basically a septic tank serving one home and one leach field serving that specific septic tank. We also can see cluster septic systems where you have a septic tank serving one home, and then you have a leach field serving various septic tank. Next slide. As I mentioned earlier, the size and the science of these septic tanks varies. That's why it's very important you follow the guidelines and regulations of your local authorities. That includes the Health, Environmental, and Building Code Department. If your jurisdiction do not have a building code department, or perhaps the building code is out of date, it is recommended to use the most recent building code, and also best engineering practices. It is very important that as you're designing and as you are installing a septic tank, you work with a professional with experience, because it can become a health hazard to your home and a community if your septic tank is not designed and installed properly. Remember, I mean, this is a type of infrastructure that deals with wastewater. There are also various materials that you can use, to build your septic tank. But again, I mean, it is very important that you follow your building code regulations from your jurisdiction. When it comes to the leach field, as I mentioned, the wastewater enters the tank, and then the wastewater is discharged into the leach field. The liquid wastewater that exits the septic tank can exit by gravity, or also you may need to install a small pump. Again, it just depends the site conditions, but those are considerations, to be considered. When it comes to the leach field design, the effluent is piped from the septic tank to a shallow underground trench of stone or gravel. A geofabric or similar materials is then placed on the top of the trench, so sand, dirt, and other contaminants do not enter the clean stone. And you can look at, and please take a closer look at the diagram that we have on the slide right now, where you can see that configuration of the geofabric and also the stone or gravel. The effluent then filters through the stone and then further treated by microbes. Remember, I mean, this is wastewater. So just by providing the time needed for those microbes to work on, that's where the treatment occurs. As I mentioned, this type of systems may not be suitable, to all residential sites or conditions. So again, I mean, it's very important, and I will stress it, that you follow, the regulations from the local authorities. Next slide. The size of the leach field needed can range depending on the number of bedrooms, soil percolation rate, the site conditions. And that's why, local jurisdictions have pre-established standards. So this type of infrastructure can accommodate, the site conditions. Talking about soil conditions, again, not all soil types have the same absorption capability. So in some cases, you will have to install a dry well, which is a type of leaching mechanism that is basically a variation or an alternative of a traditional leach field. As I mentioned, this type of infrastructure is normally installed in soils that do not have very optimum absorption capabilities. Again, checking with your local environmental department, your building code department. Certainly, they will have the information that will help you to determine what best fit to your site. Next slide. So operation and maintenance, as any type of infrastructure, it has to be operated properly. It has to be maintained properly. To these, the Environmental Protection Agency, have developed what we call the SEPTIC Smart program, where we have developed various educational materials and very good information, to help owners of septic systems to operate and maintain the infrastructure properly. Recommended practices include, but are not limited to, regular inspection of the septic tank, the leach field, pumping the septic tank. Certainly when water reaches and the capacity of the septic tank, that has to be pumped. And when it comes to how this infrastructure works with the equipment within the home, it is very important to not overload the toilets and also use safe chemicals when it comes to cleaning, washing dishes, because this water, right? If you do not have a gray water system, this water will go directly into the septic tank, and just depending of the chemicals that you're using, you may be compromising the treatment that occurs in the tank. So it's very important to do that. You can check out the EPA website. We have information in English and Spanish, and also in other languages. Next slide. The very last strategy that we're going to be talking about today is the prevention of wastewater backflows in homes. A backflow preventer is a valve, and it's very cost effective when it comes to protect water from getting contaminated from wastewater overflow. Install it where the pipes exit, so sewage only flows upward. You can see on the slide, a closer look where the backflow preventer valve is installed. Some of them already come with an already built-in backwater alarm. If the one that you have or the one that you have available do not have it, you can also buy it separately. The backwater alarm is a device that alerts occupants that a backflow is happening, and you certainly want to know when that is happening, so you stop using toilets or the other equipment that may be impacted by the backflow. Next slide. Also, maintenance of the pipes and sanitary vents. It's recommended that you connect every plumbing fixtures to a pipe that carries wastewater out of the home. And what I mean by out of the home is it means to a septic system. So remember that you need a separate plumbing system for collection and treatment of rainwater and gray water. It is very important that in all these various pipes that will be supporting, right, the gray water reuse, the rainwater, and also the septic tank, you have the cleanouts, because this is really gonna help the inspection aspect of these pipes. Since through the cleanouts you can actually do the inspections and have access to the various pipes that provide service to the systems. Next slide. Despite all the efforts that you may have, you may encounter with dealing, right, with the cleanup of backflow in a leach field. It is very important, after rain events, after disaster, you watch for pooling on your yard or in the area where the septic tank and leach field is installed. And if you see pooling, it is very important that you address it, that you tackle that rapidly, because if unaddressed, it can lead to permanent damage to your system, and you do not want to do that. If you are going to do the actual cleanup, there are general guidelines for cleanup. I think that the most important thing is that you avoid direct contact with the sewage, as it contain harmful bacteria, and certainly you have to disinfect any type of equipment that you use for the cleanup, and also you have to protect yourself with proper garments while conducting the cleanup. Well, that is next slide. That is all that I have for you today. And Lori, back to you.
Thank you so much, Paul. That was a really incredible overview of all of the strategies that someone would need to know to institute resiliency in their home for water. Septic is particularly important, and it's rare to get this kind of training. So thank you, Paul, so much. And if anyone has further questions, please contact Paul. We're going to have a Q&A at the end, because I know there's some questions coming in. But with further ado, I'd like to turn over to Jonathan Marvell.
Okay. Okay, so here I am. Can you hear me? Is that
Yes,
is this
perfect.
good reception? Okay, great. I'm sorry. I'm on a remote island in Maine. We have no electricity and no running water by choice. So I grew up on this island between Puerto Rico and this island in Maine. So as a little background on islands, it's very important to be self-sufficient and to be, as Paul has pointed out, water is one of the most important ingredients, and the second most important ingredient is energy. Without energy, we really can't do much. Transportation systems, our livability, our the health and welfare of our families, work, everything really does come down to need for energy. And so the story that I'm about to tell you about energy and particularly solar energy is a story that emerged for us in Puerto Rico shortly after Hurricane Maria and Irma. And you can see these amazing images. You can go to the next slide. The hurricanes are really transformative in our society, particularly in the areas of the most vulnerable populations. And so what we focused on for Resilient Power Puerto Rico after Hurricane Maria were the underserved communities on the island. We figured that these would be the last people to receive power after the power grid went down across the island. The first communities that would be served would be the more robust communities. And we decided that we would start a not-for-profit. This is Christina Roig and myself, start a not-for-profit. And we were in New York at the time. And we really didn't know much about energy, solar energy. And I'm not going to really give you an in-depth technical report on solar energy. What I'll do is really give you the spirit and the overarching goals for why it's so important and vital, particularly for Puerto Rico, and ultimately for Puerto Rico to be the model for the rest of the world, has the potential to be completely off the grid, completely reliant on renewable energy systems. And you can see let's go to the next slide. The 78 municipalities in Puerto Rico were our starting point. We wanted to have every municipality have an introduction to solar energy, so that maybe in the plaza you could have a solar energy system on display as a way to communicate to the people in that municipality that solar energy is viable, because there's nothing better than to see it happening and to see how simple it is for then you to put it on your own roof, whether it's in your home or your business. And you can see the after effect of no power in Puerto Rico after Hurricane Maria, a completely shut down system where only emergency areas had power because of large diesel powered generators that then proliferated around the island. Let's go to the next slide. The restoration curve, which we had tracked for Resilient Power Puerto Rico, on a person by person basis, the systems were finally 100% back up and running after more than a year of no power. And you can see the spikes happening. Slowly but surely, the island gets its power up and running. But really, the most remote places were the last to receive power, but also those underserved communities that I will talk about. And our goal, as I said, is to get Puerto Rico as an island on 100% renewable energy by the year 2030. And this is entirely doable if you do it on a grassroots basis. So if every home and every small business has the opportunity to put a series of panels on their rooftops, you will then be able to achieve on an island-wide capacity. Let's go to the next slide. and you can see on that, on this image, before you go to the next slide, can you go back once, because I think in reference to Paul's talk on water, the rooftop of this particular home has 20 solar panels on it, which can generate 5 kilowatts of energy. And I'll explain what that will enable you to do. But you can also see that we're collecting water off of the roof of this building, and we're piping it by gravity into a tank that then, before it gets into that tank, it goes through a water purification system that's also powered by the solar energy. And really, these two things, water and energy, really want to go hand in hand in order to have your home, your business, or your community center, in our case, be 100% off the grid and able to survive without power. And that's a 2,000 gallon tank of purified water that goes straight into the residence or in a community center. Okay, now we can go to the next image. And what you'll see in the next image is the communities that were affected the most, the people that really felt the impact of Hurricane Maria the worst were the informal communities. These are the communities that are marginal communities within all of the municipalities. And we've documented about 200 of these underserved communities. And you can see the blue FEMA tarp. And there's in the middle of this neighborhood, this is Caño Martín Peña and Santurce. And right in the middle of the neighborhood, the largest roof on the left-hand side of the left-hand side of the image, there was an existing community center. And this was our first prototype to test out, will solar power work on a community center that could then service the neighbors around it. So if you have documented about 27,000 people in Caño Martín Peña on both sides of the Caño Martín Peña, both sides of the canal, 27,000 people. We broke that neighborhood up into 4 groups, and we decided to try to power up each of these 4 groups with one community center with its solar panels that would then be able to create a charging system for cell phones, a place to purify water, a place to power some refrigeration so that people with diabetes could store their insulin there, and really serve as a resiliency hub. But starting with, of course, the energy from the sun. And let's go to the next slide. And in installing that system, we also recruited people from the neighborhood to watch the installation so that we can perform a series of workshops to train people in the installation. It's not that difficult, and if you see it happening once, you really are able to do that again. This image is really the backup reason why solar energy is so easy for Puerto Rico to be 100% on renewable energy. You can see the amount of sun that the island gets on overall is way beyond the norm in terms of a region globally. We have an extraordinary amount of sun that can be achieved, particularly on the southern coast, Ponce being the capital of the southern coast, the northern coast as well. The only places that lack sun are El Yunque on the right, and the peaks in Tres Picachos and Jayuya and Toro Negro in the center, in the Cordillera Central of Puerto Rico. Those are places that will be harder to achieve a renewable energy system. But everywhere else, particularly in the south, and the islands of Culebra and Vieques on the right are prime time areas for renewable energy with panels on your rooftop. Let's go to the next slide. The panels on your rooftop are key. Puerto Rico is largely an island of structures with flat roofs. Traditional roofs used to be pitched, but over the years, people have built more robust structures. Um, we've made this image as a test to see if we took the amount of power needed for the residents of Old San Juan and the businesses there. Uh, we aggregated all of their energy needs on a per person basis, and then we documented all of the flat roofs, whether they're large warehouses at the waterfront on the right hand side, or their municipal buildings in the middle, or the flat roofs of some of the larger historic buildings in like Bayaha, and some of the larger civic buildings on over on the in the old San Juan area. And so all those red roofs will indicate the flat roof potential, which we can then use to power up the needs of the people of Old San Juan. And so that kind of limited study can happen municipality by municipality throughout the island. Let's go to the next image. The understanding about solar energy and the square footages and the generation of power are we studied in order to try to analyze the amount of solar energy we would have to generate, and we, if you go to the next image, we calculated that the output of solar energy on island-wide capacity. So you saw the old San Juan area, Isleta de San Juan. Now we're going to look at Puerto Rico in general, and we're calculating that 5% of Puerto Rico's area is covered by a flat roof structure. And so if we can achieve on a roof by roof basis, that means everybody with a flat roof should be able to put solar panels on their structures, and if in doing so, we can achieve the output required on an island-wide basis, with 5% of the surface area of the island being a flat roof. Let's go to the next slide. So what we specifically experimented with, and you can be part of this experiment, is we decided to start with these community centers like in Caño Martín Peña, and we knew we had a list of these 200 informal underserved communities throughout the island. These are the barrios that are adjacent to urban centers, but are so tightly and densely occupied that if we could go from rooftop to rooftop, we could really get a bundle of energy, which is called a microgrid, together, and get to that opportunity to get to the underserved people first. And so we did some fundraising and targeted these resiliency centers. We said, let's get to 100 as fast as we can. We're up to 48 so far throughout the island, and including Culebra and Vieques. And here, so yeah, let's go to the next image. The community center typical system, and this is what we would, you'll see is what we would advise for a residence for a single family as well. On the rooftop, 20 solar panels, and we because we're using the Tesla battery system, so the dark blue on the roof are the solar panels. The next important thing are the two in red on the left side of the house, 2 battery packs, because we're storing the energy that we're producing. And we by storing the energy, that means that we can use the energy on a cloudy day, we can use the energy at nighttime. And so it's very important to have storage in the structure as well. The other key thing are the micro inverters. There's what they take the power that the solar panels produce, and they invert the current into an alternating current from a direct current, and that is what then then goes directly into your panel box in purple. That distribution panel, which you have on every home, will feed into the distribution panel, and then from there be able to go into the systems within your house that use electricity. There is a wonderful tool in addition to the Tesla batteries called the Gateway. And the Gateway, which is that small yellow square beneath the green and next to the purple, the Gateway allows you to shift from using the power coming from the city, which is called the grid from Prepa currently, and to you can use that power when there is power, or when there is no power, the Gateway will automatically kick in. But you can also use the Gateway to elect to be on your own power at any time. And so most people now have a smartphone. It's a system that you can operate off of your smartphone, so that you can be monitoring how much electricity you're producing and how much you're consuming. And so it's a very simple tool. It's easy to install, and however, these systems are expensive. So the amount of electricity that we're producing in this very particular system, which is 5 kilowatts, this costs us and we're really donating these to the community centers, $25,000 to $30,000 per community center, and that will it's fairly expensive. And so what we'd like to try to do is look how to scale that down to a much more simple system. So instead of 20 panels, 2 solar panels and 1 and 2 inverters and about 6 car batteries, you can achieve something very similar, but less. You're producing less, but enough to charge your cell phones, to have about 10 lights in your house, a fan to cool the place down. No air conditioning is really able to be supported by renewable energies, and a small refrigerator, so that if you have medicine that needs to be cooled, you can have a small refrigerator on this system as well. So 2 solar panels will be able to produce enough electricity, and that can be bought for anywhere from $1,000 to $1,500. So here's a diagram that shows you that system that you just saw in the color roof of the house, and it's it's all can be applied to an existing structure. You do not have to do this with new construction. It's all something that can be retrofitted, and a flat roof in Puerto Rico is the perfect angle, so you don't really have to raise the panels. You can put them directly on your roof on a bracketing system, so that they're not on the concrete. They're on little raised aluminum grid system that floats above the concrete roof, so that you can still keep your roof waterproofed and use it to collect water, as you saw earlier. The metrics on this diagram. So this is a really good diagram that I could share with you in an email, because this allows you to calculate what kind of support system that you would need. Obviously, you don't need the 20 panels that we're showing you on the upper right. You could start out with 2, and you could grow your own system to 2, add 2 more every year, and you can do this little by little. I'll talk a little bit about the end about how to finance these systems. So let's go to the next image. And in Puerto Rico, in powering up the community hubs, we really wanted to get to those 78 municipalities and use these as demonstration kits to inspire a source of power on an island-wide capacity. We know that maintenance and you can keep scrolling. maintenance and operations are very important. And we wanted to end this. There's the next series of images are really just how to talk about the holistic, overarching potential that renewable energies then provides you with. And these are some of the passive housing issues that you'll see tomorrow with Fernando Abrun, or next week with Fernando Abruña. Let's go to the next image. Because Puerto Rico has had the good luck of having so many historical in place renewable systems from these old colonial Spanish architecture. So on a larger scale, this is, for example, a system that we wanted to apply to a larger community group that would be in an apartment building, using the overarching comprehensive systems of water, power, and also agriculture. So if we go to the next image, you can see on a experimental prototype capacity, all of these systems working together. So the solar panels, natural ventilation, water collection devices, having a garden, having a compost system so that you can take your waste and get all of that all involved in one holistic system. So keep scrolling, because these images all really work together hand in hand with the layouts of these structures. You can start very simply on the left and grow your house and add a bedroom, and in the middle image, add a second bedroom on the right. So this idea of modularity and energy and water and architecture all start working together towards a house that we designed. So you can see on the right, single story, or you can add a second floor to it. So this is the most minimal house that we've been able to design using local craftsmanship with reinforced concrete and foam panels to pour the concrete. So we're also insulating the house, and you can see the panels on the roof. We're also using hot water panels so that you can have solar hot water systems in addition to solar energy, and of course the water collection devices. And if we keep scrolling, because these are all it's the same house with different views, and you can see the kit of parts. This is a resilient house that we wanted to make sure could work within the communities. If using the more like a DIY system where you use your own labor, you can build this house anywhere between $25,000 and $35,000. It's a simple box system of concrete, and I'll end with this image, which is to say that we ideally do not want to put our solar panels on agricultural arable land. As I said earlier on, Puerto Rico has enough flat roofs. We would like to have the land, the very valuable land that we have in Puerto Rico that's not built on. We'd like that to go towards agriculture and putting water back into the water table. And so this is a fairly common energy system that is on industrial capacity basis. And this for us is a last resort system. We believe that the island's flat roofs are able to on an island-wide capacity, on a grassroots basis, provide the power that the communities need, and grow that power from the underserved, starting with them first, providing grants, providing home ownership loans, so that anybody we know can have a loan to get a car to go to work. It's a necessity, but getting a loan to put solar panels on your rooftop should also be a necessity. And developing an island-wide cooperative to maintain the panels, and an island-wide loan system to provide loans to the families and small businesses is something that we're working on as we speak with larger energy partners. And so now I'd like to end the discussion, my presentation, and go to a Q&A with all of you and Lori and with Paul and Jose Juan Terraza, who knows a lot more than I do and can get into some details on solar energy. Thank you very much.
Thank you, Jonathan. That was an incredible overview of what's happening on the ground for lessons for residential as well as community-wide solar. And we've had a lot of questions that have come in about how PREPA and how PREPA is dealing with solar, as well as some questions about financing. I want to open up for discussion and first ask Paul a question that's been burning on several attendees about the question of how many people in Puerto Rico are on rainwater? What are your initial thoughts on the actual demand for rainwater potability?
Yes, so in Puerto Rico, I mean, at least at the top of my head, I have not seen accurate statistics about how many households, are harvesting water. However, I mean, we do know that at the municipal level, when, in the way that they manage their rainwater, at least from 20 to 30 municipalities have some type of green infrastructure, and that may include water harvesting. We do see in the metropolitan area also various examples of businesses that they harvest water, and they mostly use it for irrigation. There are some examples in Atorrey, in Caguas, and also in Old San Juan. And the water reuse that you see more often in various businesses is mostly for irrigation.
It has been said, and this is why we all prioritize these strategies in the book, that when the electricity goes out, the central waste treatment system for all water goes down as well. And we don't know what the backup power capability of PRASA is. Paul, do you have a sense of that? Because if it's true that there's not sufficient electrical backup to the waste treatment systems, then that would mean that every household in Puerto Rico should have an ability to have potable water for at least 3 days. Would you agree with that?
Yeah, I mean, absolutely. I mean, when you plan to have a water backup, as it is recommended to at least to size your cistern so you can supply your water needs for at least 2 weeks. I mean, the response from the various local agencies, varies. And certainly, since Maria, there has been an improvement when it comes to how rapidly the service is reestablished. But certainly, it is very important, when it comes to resilient, for these practices, right, that will result in a resilient community, that homeowners and businesses also have their own backup. That's why, the opportunity that you can see on water reuse, on harvesting water, is very attractive. It's very attractive. Again, I mean, if it is for drinking, it is mandatory, to follow the local regulations. But then if it is for other uses, we have the EPA guidelines on the level of treatment that is desired and recommended, and also on the water quality.
And Rafael Carrasquillo just mentioned rural areas in Puerto Rico, mountains rely on electricity to pump the water to their houses. So it comes back to electricity. It comes back to the question of, is there sufficient electricity backup available for everyone, even if you have to rely on a pump and pump the water up. Jonathan, there are a lot of questions coming in about whether PREPA is working to resolve, how do they feel about the solarizing of the houses across Puerto Rico? Are they being supportive? Is there anything that the audience can benefit from?
Yes, thank you, Lori. One big benefit that is available is in order to have batteries on your roof in your house to store your energy, you needed a permit. The weeks after Hurricane Maria, the state government allowed people to install batteries in their homes without a permit, but they had to have the installation installed by electrical licensed contractors, so that you would be able to get that permit over time. But so that opened a window for groups like Resilient Power Puerto Rico to go in and install these systems within a week or two, very quickly. It takes a couple of days to install when you have all of the parts, these solar panel arrays and the battery backup. So it doesn't take a lot of time. It takes about 2 to 4 people for the 20 panel system, but not having to have a permit was a wonderful gift, and we can continue to install battery storage systems without a permit, as long as it's permittable later on. And I think that's been a great piece of support for the renewable energy systems on the island. Other than that, PREPA has resisted the solar energy. They wanted to have the solar panels and batteries. It cuts into their subscribers, but the legislature was signed that to have the island be 100% on renewable energy by the year 2050. We said we can do it. Let's do it faster, and that's what we're working towards right now.
You have 9 years, you've 9.5 years to get there. Is there any advice you would have while the upcoming election is coming up? I mean, is there one question that came in is, is the Commonwealth on board with this? Is everyone in unison on the 2050 goal, at least?
I think it's because of the great gift that Puerto Rico has, or the 78 municipalities, 78 mayors. The mayors really have a greater impact on the local energy systems than the state government. So I think it comes down to community by community. It's a simple opportunity for individuals to get the financing in place through. These are some financial instruments to apply to banks like Banco Popular. They have funds available for people to low interest funds to take out a loan and put energy systems on your house. And so I think that's where it's going to go down. It's power to the people, by the people, not by PREPA. I think it's over time, PREPA will have to accommodate the many people that will be putting solar power on the roof, because the payback is between 5 and 7 years. It's very, very fast.
And Paul, in terms of septic, which is a big concern for everyone, is there anything that the EPA or PROS is doing to help a homeowner, for example, whose septic tank has failed, is cracked? Maybe there's an earthquake that has cracked the tank, or a flood that has disrupted the treatment. A lot of people do not have leach fields because of the land issues. What can a homeowner do to get some help immediately?
Yes, absolutely. I think, I will highly recommend, homeowners, to check the various programs from the Department of Housing. under CDBG DR. There are various funding programs that can help repairs and improvement needed on septic systems. When it comes to opportunities and funding sources, municipalities also can help. A coordination through a municipality can help homeowners access funding for repairs and also improvement of the septic systems. And also the Department of Natural and Environmental Resources in Puerto Rico, they do have a funding source, which is the state revolving funds. And that can provide relief to septic systems challenges. Another opportunity is also for homeowners is to reach out NGOs and also work with them, to develop programs that can provide relief on septic systems. USDA, the Federal Department of Agriculture of the United States, they also have like various programs. It's a combination of loans and grants that can provide repairs to septic systems.
And I want to mention to the attendees on our last session, putting it together, we're going to be going through. Sorry, I was muted. I want to thank you, Paul, for that answer. We're going to actually, on our last session, putting it together, a gift for all of you that are staying with us. We're going to be going through a list of programs that's available to help out. And the USDA does have a lot of good rural support, but these are critical questions because not only is it impactful to the housing unit, the family, if your septic system's not working, but to the community because of the impact to the community water systems as well as the water table. So this is really important to get right. And we could talk about this for a long time. We could have a whole week training on energy and water. These are critical systems. We're going to need to close up in a couple minutes. I'd like to ask Jonathan and Paul, if you have some advice for folks on the phone, in the audience from around Puerto Rico and the world in terms of water and energy, what would it be? What should their priority be when they're looking at helping to fortify their home and keep their home safe? Jonathan?
I think that the key thing for the homeowner is to start with contacting an electrician, and these are because that's your starting point is making sure that you have a home that has enough the infrastructure for adapting solar energy to it. It should be adaptable. This is a system that can feed right into a normal panel system, but you start with having an electrician and then contact the Resilient Power Puerto Rico, because we will be able to help you in terms of the basic understanding of the kit of parts. You can buy panels and inverters and simple batteries in an electrical supply store and really do it yourself. But the final hookups would have to be done by a licensed electrician so that you can get that permitted. But this is really easy to do, and 1 or 2 panels on your rooftop will make an amazing difference, and you'll feel really great about that free electricity from the sun.
Thank you, Jonathan. And Paul, please.
Yes. I mean, I couldn't agree more. These are like practical strategies that could be implemented, and you can implement it yourself. And also, you can join forces with your neighbors and local authorities. I mean, you're not alone. You're not alone, and you don't have to do this by yourself. I mean, there are various and a great interest in communities that they want to get more resilient. So call your neighbor, call your local municipality, your authorities, get informed, get a professional, and just make it happen. I mean, again, these are like practicable and strategies that you can implement.
And I want to thank you, Paul, for saying that. And I would also offer to please contact us at keepsafe@enterprisecommunity.org. We've got a whole Rolodex now of incredible leaders from around Puerto Rico that have offered their services for free, engineers and architects and builders and contractors that we might be able to send to you to help you and support you. We've got friends such as Part 9/11 or Mayamoto or AIA or a variety of Los Prometidos community groups, Habitat, that are available to support you. So you're not alone. And if you have any questions about anything we've discussed today, please reach out to us. The Keep Safe Guide is available to you to explain in further detail all of these systems in a very clear and concise way in both English and in Spanish. But you are not alone. So this is your virtual community. So please feel free to dial in and connect with all of us. We're going to be back here at the same time next week. We're going to be talking about passive habitability, which is a unique way of designing and building your home. It's a way that our ancestors built homes for generations before there was a lot of emphasis on mechanical cooling and mechanical lighting. People built their homes without the idea that there was endless amounts of petroleum and electricity. Dr. Fernando Orbruna is going to be walking us through the pathway to build and design a home so that you can live in it when the electricity goes out. Because for many of you, it's not a question of if, it's a question of when. And so with that, I want to close our session and adjourn and say thank you, deep thanks and gratitude to Paul Fericelli and to Jonathan Marvell. We are so grateful to you all, you both, for your support and your partnership today. And thank you to the many, many friends and colleagues from around Puerto Rico and around the world that are with us. Until next Thursday for another session of Keep Safe. Thank you, Andrea Russell, our entire translation team, our incredible team for social media. We're really excited to have you all, and thank you, and we will see you next week. Fantastic.
Yay. Thank you, Lori.
That was wonderful.
This was great.
Recording.
Thank you for the opportunity.
That was wonderful, you guys. Thank you so much. I think that worked out really well.
Okay, Lori,
Yeah.
I saved the chat. I think we're good. I apologize. I hit the wrong button when I put you on mute.
Oh.
So I'm like, oh my God, thank God she saw it right away.
It's fine. We're good. We're good.
Paul, you are awesome.
Thank you. Thank you.
You're a good presenter. Okay, so I'm going to shut this down now.
Okay.
Okay. Have a good night, everyone.
Hey, everyone. Lots of love to you guys.